Hello, everyone. My name is Marcus Placona. I'm a developer evangelist for a company called Twilio. Just out of curiosity, who doesn't know Twilio here? Cool. So Twilio is a communications API that helps developers like yourselves adding messaging, such as SMS messages and chat, voice, such as telephone calls, and video into the applications you're already building using the languages you already know. Okay? There's some information about me on the screen, so if you want to hit me up on Twitter later, send me an email, ask me questions. There's a GitHub repo as well. All of my stuff is open source, so you can just go and get stuff there. And I also run AndroidSecurity.info, which is a website about Android security where I talk about exploits and ways you can protect your application. So it's not a how to hack somebody else's Android application. It's more of a how to not be hacked. And I wanna start by saying I am really not a hacker myself, okay? So some of the things you're gonna see here, they are ways I found to hack other people's applications. You may be a much better hacker than I am, which is totally fine. If you have questions at the end, or if you have anything you think I could change on this talk, just let me know. The one thing I do care about, though, is security. And by the way, this is not the front of my house. I do care a lot about security. I think about security quite, most of the time. And I think about hacking other people's applications, not because I want to make any profits out of it. Most of the time when I manage to hack someone's applications, I get in touch with the developer and I tell them, hey, there's this problem with your app. This is how you could fix it. And my idea is I just want to give users a better experience, because having an application that gets hacked and you lose millions of data, like user data, is not cool. The next thing I want to say is I have this thing in here which I wanted to make sure you read it all. It's not very long. The important thing here, which I want to say, is I haven't really hacked your app, okay? First, I don't know if you all have an app. And the reason I have to say I haven't really hacked your app is because some companies tend to get, and I made this term app, so some companies tend to get suey when you go on stage and you tell people like, I just hacked this company's application, and this is how I did it. Companies tend to not be very happy about it. So I will be showing some hacks here, and I will be showing how to hack some applications. All these applications belong to me. They all simulate some functionalities on some known applications, so you might see that. But all these applications belong to me, and obviously I gave myself permission to hack them. But without further ado, I just wanna kind of go through real quick here how HTTP requests work, because I think most of you know how it works. Like, most of you know how an HTTP request works. Basically, you have a user. The user makes a request to a server, and the server then just replies with an answer. Pretty simple, okay? Now, what have I just done on the beginning of this presentation? I've included an extra character in this, which in hacker terms, this is called a man-in-the-middle hack, okay? So what I did was I got access to the user's requests, and then I proxied those user requests into the server. So now, instead of a user making a request directly to the server, the user makes a request to me, and I pass that request on to the server. Then the server comes back to me, and I pass it to the user. So the user is none the wiser. The user doesn't know what's going on here. I do. I get access to everything. I get access to all the information that user is passing, as you saw right now. So I got access to their API. I got access to their passwords. I can basically get access to anything there. And why is this important? And why I want to grab your attention to the next slide, because I think some of you will... Who's still playing Pokemon Go here? Oh, a little bit. Yeah, a little bit. So why is this slide important? And why does it go back to our man-in-the-middle attack? Because of this. If you are playing Pokemon Go, you will know that this doesn't exist on the game. Okay? So the premise of Pokemon Go, if you've never played it, the premise of it is you walk around, so you have a character, you walk around with your phone on your pocket, and you catch Pokemon. That's pretty simple. Not only you catch Pokemon, but you get extra things for when you walk around too much, when you, like, every 5 kilometers you walk, you get some extra things. So that's the premise of it, okay? However, someone or a group of people didn't really want to do that. They didn't really want to walk because they were like, well, walking, I'll get tired if I walk. So what they did was they said, okay, so how does the application work? How does the application tell the server when I'm walking or when I'm not walking? And they, through a man-in-the-middle hack, they found out that the application communicated with the server without a token, without any sort of like encryption. So they got access to the API. They got access to the Pokemon's API. And with the Pokemon's API, they built this into the application. So right now, what you could do was you could just tap those buttons and your character would walk. Okay? So I just want to point something out here, that the motivation here wasn't to steal anyone's information. The motivation here was to catch Pikachus. Okay? So we're not talking about a group of hackers who will hack a bank. We're talking about a group of hackers who wanted to catch Pikachus. And so that's their motivation, okay? But let's save these words, motivation, because we're going to see some other more interesting hacks that involves motivation as well. The next one I want to tell you about is Kuba Gretzky. So has anyone heard about Kuba Gretzky? Kuba Gretzky is a Polish developer who realized that there was some way he could hack an application to get free beer. Again, motivation. Much bigger motivation this time, okay? The one thing I always like to point out in this specific image, so I don't know if anyone reads the register, it's just like a news website, but the way they describe, and if you can't read this, this says a strangely dressed man drinks beer. So that's how they see a Polish hacker. Is anyone here Polish? Like, is that how you dress when you hack? Probably not. No. Yeah. So probably not. But anyway, I always like to point out to this. But let's go back to Kuba's. The way Kuba managed to hack this application was through loyalty. Okay? And that's the way he also got to get some free beer. Kuba found out that there was a mobile application in Krakow that you could download, and every single time you went to a bar, the bar would scan your application, and you would get an extra stamp. So pretty much like what Starbucks does. Like you go to Starbucks, you have a card, or you have your app, they give you like an extra stamp, and for every 15 coffees you get a free coffee, something like this. Except that this was in Poland, and what they were giving out was beer. Every 5 beers you bought, you would get 1 extra beer for free. Okay? So again, the motivation here is very different because beer was really the interest. Okay? What Kuba Gretzky realized was that when he used this app, there was this scenario here going on. Okay? Kuba would use the app. The app would make a request to an iBeacon that was on the premises. So this would be a bar or a restaurant. The iBeacon would then return a message to the app. The app would then know how to go to the server and say, Kuba Gretzky just bought a beer, let's give him a token. Pretty simple, right? It was so simple that he actually realized this. And what he did was, he used an HTTP proxy in the middle here to see what kind of requests this app was making. Okay? When he did that, he got access to the following information. This is the real thing. This is the information he got access to. He got access to the URL he had to call on that website. He got access to the authentication token, super important because you can only make requests with an authentication token. And he got access to information about the iBeacon. And he also got access to the promoted products, which in this case had more than beer, but he was only interested in beer. Okay? He then realized that if he was to make a request to this same server, he would start getting free beers. Okay, so every 5 requests he made to this server, he would get 1 free beer. And he could make those requests without buying any beer. He didn't have to go anywhere. He could be sitting at home, and he could be like refilling his application with free beer. So next time he went to the bar, he would say, hey, I'm buying the rounds, and it's all free. So obviously, Kuba Gretzky got access to an unknown amount of beer, okay? So yeah, this is, again, Kuba Gretzky being very happy with his beer. So he got access to an unknown amount of beer. And what happens next was Kuba Gretzky wrote a website. So he wrote a blog post on the 18th of August. So this is when he hacked the application. So he hacked that on the 18th of August, 2016. You can't see on the bottom, but the last time he published something was on the 28th of July, 2016. So Kuba used to publish stuff every month or so. This was his last blog post. So now, I don't know if Kuba Gretzky has been drinking beer ever since, or if something happened to him. But obviously, because he got access to like an undisclosed amount of beer, he's probably been drinking beer. So he's not been blogging ever since. But now let's just talk about what could the developers have actually done to stop this. Because Kuba Gretzky was not a hacker; he was a developer. So what could the developers, like who built the application, what could have they done to actually solve something like this? And I'm going to talk about a few of those things. Okay. The first one, which seems really obvious, is encrypting all the values. Like as you saw, they were making an HTTP request, passing a JSON packet with all the information about these free drinks. Okay. That was plain text. Like, Kuba didn't have to do anything special. Like, he had an HTTP proxy in the middle, but that was it. He didn't have to do anything special to get access to this data. Encrypting values. Is anyone an Android developer here? Cool, some. So encrypting values and it really depends on your language, on your programming language. But if you're on Android, there's like this really nifty library you can use to do encryption. And the way it does is you add your library, then you can encrypt a string, and you can decrypt a string, okay? Just keep in mind that you have your password right here. You have your encryption key right here. This is not a good practice. I'm not advocating this, and I will talk about this later. But in this case, just for the example, you have a password right here. We'll talk about this later. But this is how easy it is to encrypt a value, okay? You don't need to be an amazing developer to be able to do this. If you have developers who aren't encrypting their values, and you ask them, why you're not doing this, and they say, oh, because it takes too long. No, it doesn't. This is how you do it. Super simple. Now, the reason why I pointed out that we had a password in this app is because eventually your keys are going to end up in GitHub, okay? Has anyone had this problem, like committing a key to GitHub, pushing like an API token to GitHub, and just like panicking for a bit, and no one wants to raise their hands? It's okay. I had this issue. But let me tell you about this specific case here, where someone published their AWS keys to GitHub. What happened was, their AWS keys were on GitHub for 20 minutes. Okay, only 20 minutes. And by publishing their AWS keys, there's people who basically track every single pull request, every single push into GitHub. And they look for things like passwords, authentication, tokens. They look for all these things. And when they find these things, what do? They start using it. In this case, what the hackers did, or what the people who got access to his keys did, was they spun up a bunch of servers to mine Bitcoins. Because this is what you do, right? And in 20 minutes, his bill was $3,493. He realized this in 20 minutes when he got an email from Amazon saying, hey, thanks for using Amazon. And he was like, what's going on? And he looked at his bill. It was that much money, and he panicked. He tried to delete, but the thing is, once it's on GitHub, it's really hard to get rid of it. Like, you can go ahead and like delete your repo, but once it's there, it's really hard to get rid of it. He was lucky because he found a bug with Amazon as well, because every single website that offers you a key, every single website that offers you an authentication token, also offers you a way to recycle this token in case you make a mistake. He recycled this token, and people were still using his key. then he realized that Amazon was actually caching the token. So even by recycling, Amazon could still, people could still use that token for a few minutes. And that's when Amazon said, yeah, it's okay, we're not going to charge that much money because you found a bug in our system. So it was almost like a bounty he got. So yeah, this is why I'm saying it's important to make sure that you are keeping your keys safe, that you are not keeping your keys in the application, because otherwise you're just giving them away. Other things that could have been done in this application is utilize security feature. Remember, like when I said, Kuba got access to the iBeacon as well, all the information about the iBeacon. If you ever used an iBeacon, you will know that cloning an iBeacon is very easy. You can do it through the app. So iBeacons aren't very secure. These ones were not secured at all. But it turns out there are ways you can use security features on iBeacons. It's just that these developers didn't use them, okay? And it was obviously in Kuba's favor that these developers didn't use them. So that's one thing they could have looked at as well. The other thing is certificate pinning. Certificate pinning is one of the most important things right here, because when you build a web application, your application runs on a server. When you build a mobile application, the application does not run on a server. When you build a mobile application, it runs on the client's hands. It runs on a mobile phone. With certificate pinning, you can make sure that if you have an SSL certificate to communicate with an API, you can make sure that only your application can communicate with this API and vice versa. So there's no way someone can come in the middle and spoof the HTTP certificates, like I did in the beginning here. If I was using certificate pinning on that app, I wouldn't have been able to do that. Now, adding certificate pinning is a bit more involved. If you are an Android developer and you use something like OKHTTP, for example, then this is what it takes. Like, you've got your website, you've got the pinner, so like you've got your public key here, and then you just go ahead and add that certificate to your application. So right now, your application can only talk to your website as opposed to anything else. So it's really simple to do, and most people just don't know about it, because especially web developers are so used to think that because I have HTTPS on my website, everything is okay. On mobile, that's not the case. On mobile, that's not true. Now, the other thing is, do not trust the device. Like I said, when you're running an application on a device, anything can happen. Like, this is my device. I can do whatever I want to do with it. If I want to take it apart and try and look for things inside, I can do that. So don't trust the device. Because when you trust the device, eventually, someone's going to go and decompile the application. Okay? That's going to happen. Someone will go and decompile the application. Now, I'm showing you a website here, which is not a hacker's website. This is not a hacker's tool. This is a developer's tool. Developers decompile applications to find things. And some of those things will sometimes be, well, I'm going to decompile this application because I want to see how it works. Or I'm going to decompile my application to see if I'm exposing anything I shouldn't be exposing. So developers will use this as a tool, okay? So this is not a hacker tool. This is a developer's tool. Now, what is involved in decompiling an application? Really not much. This is how I decompile an application. So apk2d, name of my application, boom, decompiled. That's not too complex. Then what I can do is I can start looking for things inside this application. So I'm looking for things like oath. I'm looking for user, password, and yes, I found a password. So it didn't really take me long. Like, I decompiled this application, and I found a username and a password. Not hard. Very easy to do, okay? But then I have people telling me, like, but I need some magic strings. I need to have those strings in my application. And I understand this, because if you're using an API and you want to have a token, like if you want to have access to this API, you will need to have a token inside of it somehow. Some options you have right here is you can encrypt that token. So that's like one way you can get away with not just having the token inside the application, just encrypt it. And if you're using your own API, if you're accessing your own API, what you can do is you can decrypt it on the other side. So you can encrypt here and you can decrypt on the other side on the server. Obviously, if someone gets access to your server, then you have bigger problems. But other than that, it's a good way to make it, it's a good way of making sure you're not giving away your keys in plain text. The other thing you can do is you can just get keys from the server. Like, you don't need to have those keys inside your application. You can make requests to the server. If you use certificate pinning, for example, you can make requests to the server so you get those keys from the server. And obviously, you would use like proper authentication and everything, but it's one way you can do things. There's a third way, which I don't know if you noticed. I have some URLs at the bottom of the slides. I will be publishing those slides later. But I have some URLs here which will give you some more information about it if you want to read more. So you can, if you're an Android developer, you will know this. The NDK is the native. It's the native development kit. So it's basically a way for you to get lower level inside Android. So you don't need to do just Java. You can actually do C, C++. And then one thing about C, C++ is when you decompile it, it looks like nothing. When you decompile Java, like if you've ever decompiled a Java class, you can read everything, and it's so perfect. When you decompile C, C++, it looks like nothing. So that's one good way for you to store. If you have to store magic strings inside your application, store in the NDK. So this is a blog post that shows you how to do that. And it's actually very simple. You can still build your entire application using Java, but if you use the NDK, you can actually store some of the information there, and you just call those modules. But I talked to you about things developers can do to stop. But stopping is not good enough. Because when you've been hacked, when something happens and you try to be reactive about it, it's already too late. At this point, you lost users. At this point, your application has like 1 star. And they have really bad reviews. Because at this point, you're screwed. Like, if your application got hacked, at this point, there's really not much you can do. You can try to stop it. But when people got access to your information, that's it. Now, I like to think of a proactive way. I like to think about things that you can start doing from the beginning. As a developer, you can be proactive about these things as opposed to being reactive. So being proactive means you can do something like adding tampering detection, for example. So tampering detection is great because you can now know when someone decompiled your application, republished, renamed, or did anything like this, you can now know and you can react to it. Adding tampering detection is this simple, so there's not much here. I'm basically checking, okay, so what's the name of the application? And if it's not the application I built, I can just give a message to the user saying, hey, don't use that. This is not the one I built. I'm also checking if the application has been installed from a different market. So obviously, you know things like the Play Store, you know things like the Amazon Store, but there are hundreds of alternate markets out there, okay? And the reason some people republish applications in alternate markets is because, say, your application uses ads, for example. A common thing to using mobile in Android development is if you have ads, you have something like AdMob, and everyone who uses your application, if they click on the ads, you get some money out of it. The reason people republish applications is because they want to change the ID of the ads. So they want to start making money out of your app. Okay? So you can detect those things as well, which is kind of cool, because now you can say, hey, I didn't publish this application in this market. So you can force close. You can give a message to the user saying, if you want to carry on using this application, it's fine, but like, I'm not responsible for it. You're on your own now. So you have control. You can make a decision right here. The other thing that is important and the other thing that is super easy is check the application signature. Every single time you publish an application, every single time you put an application in release mode, you get a signature. Just check that. If anyone recompiles your application, the signature will be different. If you're checking for that, then there's really no way people can get anything out of your app. And this is how, this is what it takes. Again, there's a URL at the bottom, so if you want to look at this code later, because I know you're not going to remember it, then there's a URL here. Check for rooted device. And this one, I like to, there's a caveat on checking for rooted device. There's a lot of rooted devices out there, okay? If you are going to stop everyone from using your app, because they are on a rooted device, your user base will go down by quite a lot. Again, if you're a bank, yes, you should stop users from using rooted devices. But if you just have an app that doesn't have too much important information in it, then maybe checking for rooted devices is not the best. Checking for rooted devices is super easy. Basically, what you're trying to do is, if you're a Linux user, for example, what you try to do is you try to execute a command in the phone. You try and execute something like su, for example, so you get to super user. And if you can, that device is rooted, right? So this is one way you could do that. There are applications that hide root and everything, so they just keep on getting clever and clever on this. But this is one way you can check that. So just check for a rooted device, and then you can make a decision, depending on how important the information you have in your app is. Check for emulator. This one is a no-brainer, okay? When I build an application, it needs to run on a device. It doesn't need to run on an emulator. If anyone is trying to use my application from an emulator, they're probably trying to do something dodgy. Checking for an emulator is as easy as this. So you check for the build fingerprint, and if it's generic, it means it's coming from an emulator. So you can add this flag to when you release your application. So you can still build using the emulator. I'm not saying you should build using just a mobile device. You can still use an emulator, but when you publish the application, you can change that. And that's like a great way, because most of the applications who get hacked, they get hacked through an emulator. Because it's so much easier. Like, you don't need a device. It's so much easier. Check if the application is debuggable. And this one usually raises eyebrows, because people go like, well, if my application has been released, then it's obviously not debuggable, is it? Because it's in release mode. So I'm going to show you how to check if an application is debuggable, and then I'll show you how to change an application to become debuggable. So I'm basically just checking for flags. I'm checking for a flag debuggable in the application. And if it is debuggable, I'll say it's debuggable. Don't continue this. But now, how do you make a release application debuggable? Super easy. Open the application, change the manifest, debuggable to true. That's it, application is debuggable now. The APK is debuggable. I can go and recompile this APK, and it's now debuggable. I can debug it, I can get information from it. And obviously, when an application is debuggable, I get access to a lot more things than an application that is in release mode. And this is usually the point when people say, I'm lost. Like, you've been talking about so many things. Like, how can I do? Like, like, I haven't done any of those things before. How can I start? Where should I go? Where should I start? Few things to look at. ProGuard and DexGuard, they're both from the same company. I don't work for that company, so I'm not trying to advocate the product. But ProGuard comes installed with Android Studio, for example, and DexGuard is a paid application. What ProGuard does is it's installed by default, so if you have Android Studio, for example, chances are your project already has ProGuard, unless you disable it. It does name obfuscation, so whenever you publish your application, whenever you change the application modes to release, it changes the name of the functions. So when you have your function like get super secret password, that will turn into bananas, for example. So it changes the name of the methods, and that's great, because now it's harder for people who break into your application to get information from it. It does code optimization as well, so it does a bit of tree shaking. So if you have libraries, or if you have classes that you're not using in your application, it will remove them, which is great, because you have limits in Android. And it does, removal of redundant code, same thing. DexGuard does a bit more. So DexGuard does some of the things I just mentioned here. So it does class encryption, for example, which is really cool. Class encryption in DexGuard is great because it's not only using the regular characters we used to, it uses some Chinese characters as well. So now your classes will be renamed in a much harder way to read, unless you know Chinese. Call hiding through reflection as well is super important. All the other things like string encryption, it does certificate pinning checks as well. So if your application is not using the right certificate, or if there's something trying to get information from your application, it will do that. It does debug detection, emulator detection, root detection, so it does a bunch of things for you. A bunch of the things I just showed you here, it does it for you. Now, why would you use ProGuards and not DexGuard? First, ProGuards is free. DexGuard is not. DexGuard costs, they have a weird licensing model because DexGuards can cost anything from like 4,000 euros to 18,000 euros, depending on your user base, and prices go up, okay? So it's something to keep in mind. If you have something that you really want to protect and you think the costs here are worth it, then yeah, totally go for DexGuard. If not, ProGuards is a free option and you can roll some protection your own. It's just that it's going to take more of your time. Other things to look at. The other two things I'm going to talk about, they are free, okay? SafetyNet API is an API by Google, and what it does is it checks if the device is compatible. So if the device, when I say compatible, I mean compatible with the Play Store. If the device is compatible with the Play Store, cool. If it's not compatible, you get a report. So you get something back saying, hey, this device is not compatible. What do you want to do? And that's the time when you say, I want to carry on, or no, I'll just give the user a message saying, don't use this app because there's something like I can't guarantee. It checks if the device is rooted as well when it tells you. So it's not going to block anyone, but it gives you the option, okay? Now, the reason why I like using the SafetyNet API more than checking if a device is rooted myself is because the SafetyNet API just keeps getting updated. Like, hackers get clever every single day about how to hide the fact that a device is rooted. This API kind of tries to keep up with it, okay? Otherwise, if you don't use something like this, you will need to keep up with how the hackers try and hide the fact that a device is rooted. Then you have the network security configuration as well. Network security configuration, another free tool by Google. And what they do is they do certificate pinning for you, so you don't need to do that yourself. They do debug overrides. They do a bunch more things as well. So they do they check for the text that you're passing. They check for things like, hey, are you passing a password or something? They check for that and they let you know, okay? So it's pretty good. There's one caveat with it, which is it only works in Android Zen. So the official version only works on Android Zen, which is one of the latest versions of Android. They just released Android O right now, but N is pretty new. However, someone called Mark Murphy actually backported this API to Android 4.2, which gives you a bit more like room for wiggle. Now, I've only got 5 minutes, and I wanna make sure if you have any questions, I wanna give you some time for questions. But I wanna kind of close this by saying the web is not safe. Not everything you see is what you're really gonna get. Okay, I can pretty much guarantee this is not going to Hannah Montana show. Okay, and it's the same with mobile, it's the same with the web. It's not a safe place. You need to make sure you look after things, you need to make sure you look at things, because when it comes to safety, you need to make sure you protect yourself. With that, I've been Marcos Placona, developer evangelist at Twilio. I'll be around today, so if you don't get a chance to ask me any questions now, then you can ask me later. There's some information here. Thank you very much. Do I have any questions? Or do you want to come over and ask me questions? It's fine. I'll just wait for people to come and ask me questions.